it looks like they knew ahead of time, even in the 5th century, that this solar system was going to work its way back around to where it would line up with a gravitational tube or a portal, or what we call in science fiction a wormhole. Of course, our physics community, even in theory, we don't believe that a wormhole would be stable. And the reason we commonly say that is when we work out the math of it, we realize that it has to be built with what's called exotic matter. We would say that would be neutron star matter, because we just don't have anything dense enough on this planet to even think about it. But it's commonly constructed from the inside out, and what it does, it opens up vacuum fluctuations between one part of the universe and this part of the universe, and it's kind of like sticking the microphone up against the speaker of your stereo and turning the volume up full blast. Only the amplifier doesn't clip. It destroys both sides of the wormhole. And the interesting thing is, because you're linking vast distances across space, it appears to collapse before it ever forms.
Isn't it amazing that they were able to do this with help, let's say this visitation indeed occurred, and here we are getting close to these dates, and things are beginning to happen. And I'll tell you the other thing that I find fascinating. The collider, the particle collider in CERN in Switzerland, that is coming online this year, and, you know, they're heating it up as we speak and cooling it down, but it's going to go online. This could cause a hole, they say. It could cause mini black holes. Isn't it bizarre that it's only several years away to 2012 as well?
Well, it's even more bizarre that the coming of the super collider, the actual formation of these mini black holes, was predicted by ancient civilizations. They actually talk about these instruments being toyed with by modern society, and they tried to leave us a warning not to do it. A lot of people don't know how a super collider works. We've built several small ones. We take gold ions and we accelerate them with electromagnetic accelerators at each other, like two fire hoses aimed at one another. And occasionally, the two ions hit head-on. Usually they glance off one side or the other, but when they hit head-on, they annihilate each other. And in that annihilation, they blast subatomic particles up against the detectors, and even if they only exist for a billionth of a second, we get to see what the subatomic particles, the protons and neutrons, are made of. Well, we've done it, but not really done it well because we haven't had enough power. But this CERN super collider is powerful enough to make it happen. This Hadron Collider will actually form miniature black holes. Now, they'll be the size of a proton, but gee, if I remember my descriptions of the Big Bang, wasn't the whole universe in a spot called a singularity about the size of a proton?
Absolutely. Absolutely. Well, now, what are the other factors, though, that could contribute to what's going on now?
Well, of course, we have dark matter and dark energy, which makes up 94, some people say 94, some people say 96% of the universe. And we don't really know the nature of dark matter and dark energy, but we can see its effects on the matter that we can see. Some people claim that it's energy that is in the process of collapsing from wave function to particle function. Some people say it's just beyond the spectrum of anything that we can see or detect. But we do know that the universe is packed with it, both dark matter and dark energy. And we know that it's not uniform throughout the universe. It's moving much quicker at the outer parts of the universe than it is in the inner parts of the universe, and that's a good question by itself. Which part is the inner part and which part is the outer part? As it turns out, in our perspective out here at the edge of the Milky Way galaxy, we don't really have a good ruler to measure it, because the furthest extent that we've sent a satellite out, and it's not even equipped to measure those kinds of things, is about the edge of our solar system. So we just don't have great perspective. But we really honestly believe that the Mayans and, possibly the Atlanteans and the Lemurians, that they understood these greater forces in the galaxy and the universe because they came from those places to here. And they brought that knowledge with them. And if that's not the case, then they were taught by others who did come from those areas. There's just no way to measure those things from Earth. But in answer to your question, we are now nearing a place in the galaxy where new responses are happening in this ecosystem we call Earth.
Which we can't even figure out yet.
Well, a lot of people can figure it out, but it's slow-moving in science. Even though we have the Internet, even though we have a lot of very bright people that are getting access to data like never before, in science we have kind of we have a religious community of peer review, and it's slow to get new data to come forth, and it's very difficult to get your hands on funding to launch another NASA program. We now have 67 active NASA programs in space, and the funding is spread thin over all of them. So you basically have grad students, which are one notch above slave labor, working on them until they can get their PhD, their postdocs done, and then get out and get a real job and start supporting a family, because you're not going to do it working for NASA. We just don't get the best data quickly enough to respond, and we're 5 years away at best from this 2012 date, this crescendo. And if we're going to respond to it as a human race, we need to react now. We need to get new science, new energy, new places of refuge now.
We could have a total polar shift, yet science doesn't even talk to us about this. And it's a very real possibility.
Of course it is. We have taken geological samples up near the Arctic Circle that show a very broad range of alignments of the poles of the Earth. Now, these alignments occur when lava comes up through the crust and then it freezes. It assumes the magnetic alignment of the Earth at that time. Well, when we go up near the Arctic Circle, we see these tectonic spectrums of north and south pole alignments in mountains and in rock that hasn't moved for hundreds of thousands of years. And guess what? Sometimes it shows the north as south and the south as north. And this is, according to the Coriolis effect, something that could occur rather quickly, like in a matter of days. The north and south poles could switch. Now, we could talk a little bit about what the effects would be on the surface of the planet if that should happen.
Yeah, I'd love to know, because there's some people, and I've asked this question, Brooks, many times. Some people believe that we could go instantly. Other people think it's gradually, and some people think nothing will happen at all, which I don't believe. I think it'll be pretty drastic.
There's too much evidence that the poles do shift. North and south poles do shift. And if the core is detached from the crust, as we believe, and the core is thus counter-rotating against the crust, creating our powerful magnetic field, which we call a magnetosphere, if all those things are true and line up, then we are setting ourselves up, or the planet is set up to do a Coriolis flip, that the north and south poles could flip. And I mean in somewhere between 72 hours and 5 days, this flip could be complete. Now, it doesn't take an atmospheric physicist to understand what's going to happen, but I'll explain it briefly. The north hemisphere and the southern hemisphere have different weather patterns. For instance, if you drain water down the tub in Australia, it goes clockwise instead of counterclockwise, and opposite up here. Well, the jet stream does exactly the same thing. Clouds move counterclockwise and clockwise in different areas, and so do the oceanic currents. If all of those things move, and move suddenly, you're going to have conditions set up for what's called a global superstorm. Now, these are snowstorms, but they're not ordinary snowstorms. They are super cold, and they cover large geographic areas.
And in terms of the intensity, how intense is it?
Well, according to what we've uncovered in the book, and this goes back 26,000 years as far as we can gather data, we could be facing winds of 300 miles an hour, and those winds could last for a month or more.
That would knock down practically everything.
Once you got sand and glass